Hello everyone and welcome back to yet another video in this video series which is called as Target JEE Advanced, brought to you by BYJU'S. So in this particular video, we are not going to focus on any chapter in particular, but I'm going to give you a few tricks of the trade to solve JEE Advanced questions quickly. We're going to look at some past year questions. I've picked a few questions for you to illustrate certain tricks of the trade that will help you solve advanced questions quickly. Now, believe me, JEE Advanced is not an examination that can be solved using shortcuts. So don't expect any shortcuts in this particular video. This video is for people who are very well prepared for the examination and you understand that certain tricks can be incorporated with a lot of practice. You see a question, you identify the pattern in the question, and you adopt a particular technique to solve this question. So in this video, it'll be full of such tricks because JEE Advanced Maths does not really come with a lot of shortcuts. Here are a few questions which have interesting tricks and that will be solved much easier than the routine method to solve these questions. In this question, we have to find the number of real solutions of this particular equation in the interval -half, half. So how do you get into solving this question? Well, there are a number of tricks in this question to solve it. So step by step, let's analyze what are the different things that we need to apply in order to solve this question. The first thing is, on the left hand side I have a sine inverse, on the right hand side I have a cos inverse, but there is pi by 2 minus cos inverse, which can be written as a sine inverse of this same argument here without any change to the argument. So I have sine inverse of something equal to sine inverse of something else. So this means that the arguments have to be equal because sine inverse is a 1-1 function. So we are going to get the arguments of both the left hand side and the right hand side to be equal. We get as the summation of x from x to the power I plus 1 minus x times summation x by 2 all to the power I. That will be equal to summation of negative x by 2 to the power I minus summation of negative x to the power I. So in all of these summations, I is running from 1 to infinity. The next trick is to actually solve these summations. You will use the trick of geometric progression. So all of these are infinite geometric progressions. And remember, your x is in the interval -half, half. So these are infinite GPs with common ratio, the magnitude of common ratio to be less than 1. So you can solve all these using infinite GP concept. So if you solve using infinite GP concept, you are going to get x square by 1 minus x as the first term minus x times the second term will simplify to x by 2 minus x, which will be equal to negative of x by 2 plus x. That will be the summation of negative x by 2 all to the power I minus, well, summation of negative x to the power I will be nothing but minus x by 1 plus x. So if you simplify this, this is what you will end up getting, and immediately you get one root because there's an x common in all of the numerator. You can take that x to be common out, and x equal to 0 is going to be one of the roots and x equal to 0 lies in the interval -half, half. So definitely this equation has one real root in -half, half, and that is equal to 0. So the next thing that you do is you are going to cancel out that x that you already considered, and then you will take a common denominator and systematically solve the equation. Eventually you will end up with a cubic equation. The cubic equation is going to be x cube plus 2x square plus 5x minus 2 equal to 0. Now you need to find out if this cubic equation has a root in -half, half, and that's where the next set of tricks are going to come into picture. What I'm going to do is I'm going to differentiate this. So if I take this as my function f of x, so if I differentiate f of x, what will I get? I get 3x square plus 4x plus 5. It's a quadratic expression, and if I equate this to be equal to 0, then you have a quadratic equation. And what is the discriminant of this quadratic equation? Well, it is 16 minus 4 times 3 times 5. Well, 4 times 3 times 5 is definitely greater than 16. So discriminant of this is less than 0, which means this quadratic has no real roots. This means f dash of x is never 0 for any real value of x. which means that this function is going to be either always increasing or always decreasing. Well, if you put any value of x, you will see that this equation will always be an increasing function. So this function is going to be an always increasing function. And if you take the limit of this function as x goes to negative infinity, the value of the function will go to negative infinity. If you take the limit as x goes to infinity, then the limit will also go to infinity. So this means that the function changes sign from negative to positive, and it's an always increasing function. This means that it definitely has one root. So x cube plus 2x square plus 5x minus 2 has one root. This is the trick to identify that it has one root. Differentiate the equation, identify the nature, the monotonicity of that function, and then find out how many roots it has. It has one root. Now, that's not it. We need to find out where this root exactly lies, because we are interested in finding the root in negative half comma half. So what happens if you put the value of x equal to 0 in f of x? Well, if you put x equal to 0 in f of x, you're going to get a value minus 2. So f of 0 will be equal to minus 2. F of 1, well, f of 1 is going to be 1 plus 2 plus 5 minus 2. Well, that's going to be some positive number. So f of 0 is negative, f of 1 is positive. This means a root exists between 0 and 1. So this is actually another trick to basically narrow down your interval to find out where exactly that root lies. So let's try and find out what is f of half. So f of half, well, that's going to be equal to 1/8 plus 2 by 4 plus 5 by 2 minus 2. Well, 5 by 2 is greater than 2, so 5 by 2 minus 2 is definitely greater than 0, and there is that 1/8 and 2/4 also added to it, which means f of half is also greater than 0. So f of 0 is negative, f of half is positive. This means that the root clearly exists between 0 and half. So there is one root between 0 and half. 0 is already a root. So we have two roots in the interval negative half comma half. So this is how I solve this question. It is not a simple question, and the tricks here are not very obvious tricks. But without these tricks, you will actually not be able to solve this question very soon. So in the advanced examination, you have to solve this question in real quick time. You will have to make use of these tricks to solve this question and arrive at the solution. Now here is a very interesting question, which at first sight seems to be a monstrous question, but which in reality is a very simple question. So here's the question. So the objective in this question is to find out the points of discontinuity of this function, which looks pretty complicated. F of x equal to x times cos of pi times x plus greatest integer of x. Pretty difficult looking question on first sight, but let's use the properties of greatest integer here. If you look at the options, we just have integer values in the options. So let's see what happens to the greatest integer function at these integer points. So let's consider x equal to 1. So what will happen to the argument of cos? Well, the argument of cos when x is slightly less than 1, so in the limit of x tending to 1 from the left hand side, what happens to the argument? The argument is going to be pi x plus the greatest integer of some quantity slightly less than 1. So it is going to be pi times 1 plus 0. So that's going to be equal to cos pi. So x is 1. So x is so the limit of x tending to 1 minus of f of x will be 1 times cos pi. But what happens on the right hand side? Well, when you come from the right hand side, this is going to be equal to 1 times cos of pi into 1 plus, now the greatest integer of some number which is slightly more than 1 is going to be equal to 1. So this is going to be equal to cos 2 pi. So cos pi, if you notice, cos pi equal to negative 1, but cos 2 pi is actually equal to 1. So the limit does not exist at this point. So at all integer points, cos of pi times x plus greatest integer of x is going to be discontinuous. But hang on, Do not mark all integers as the correct answer to this question, because you have an external x which is multiplying this function cos of pi x plus greatest integer of x. So what happens because of that x? As long as that x is not equal to 0, nothing really changes. Your discontinuity is going to exist because of the limit not existing at those integer points. But what happens if x equal to 0? Let's consider limit x tending to 0 from the left hand side of f of x. Well, irrespective of what the value of cos is, well, this is going to be equal to 0, because you have 0 multiplying cos of pi times 0 plus some number slightly less than 0, which would be minus 1. So you'll have cos minus pi multiplying 0. That's 0. Similarly, limit as x tends to 0 plus of f of x, that is also going to be equal to 0 times something, which will be 0. So the limit will exist at x equal to 0, and also the value of the function will be equal to 0, which means that the function will be continuous at 0. At all other integral values of x, the function will be discontinuous because the limit itself doesn't exist at these integer points for x. But at x equal to 0, the function is indeed continuous. So the points of discontinuities will be all integer values other than 0 for x. Again, a question that you could have solved without lifting the pen. It's a question that you could have solved just by looking at it the first glance, 10 seconds, and this question should have been done. Now here is yet another very interesting question which you can solve without lifting your pen at all. So let's have a look at this question. In this question, the objective is to find out which of these 4 given matrices cannot be squares of another matrix. So these 4 matrices have been given to you. We have to determine if these matrices could be the square of some other matrix. Now, people who are going to sit and solve this question mathematically, well, it's going to take you ages to solve this question because it's a very complex question and way beyond the scope of your 11th and 12th standard syllabus. This needs complex linear analysis in order to arrive at the solution. You have to go through things called as eigenvalues and eigenvectors to arrive at the solution, which we're not going to do. We're going to in fact solve this question in no time at all, because we're going to make use of one property which a lot of you will not remember. Imagine that your A square is some matrix B. Okay, so if A square is the matrix B, then the determinant of B will be the determinant of A squared. Okay, it will be the determinant of A whole squared. So for any matrix to be the square of another matrix, its determinant should be the square of the determinant of that matrix, correct? So this means that the determinant of a matrix which is the square of another matrix cannot be negative. So if there is any matrix whose determinant is negative, it clearly means that it is not the square of another matrix. Now let's look at the matrices that we have. Well, the first matrix, it's a diagonal matrix. The diagonal elements are 1, 1 and -1. The determinant of that matrix is -1. So clearly the first matrix cannot be the square of any other matrix. So that is one of the correct answers to this question. Look at the second matrix. Well, that's also a diagonal matrix and its determinant is equal to 1. So it could be the square of some other matrix. We don't know that. So that is definitely not a correct answer to this question, because it is for certain not a square of another matrix. We cannot say that. What about the third matrix? Well, the diagonal elements are all -1. It's a diagonal matrix. Determinant is equal to -1. So since the determinant is negative, clearly this matrix cannot be the square of any other matrix. And the fourth one, well, that's an identity matrix, and we know that the identity matrix is a square of itself. So that was definitely something that we wouldn't have marked anyway, because we already know that the identity matrix is the square of itself. So this is how we solve this question without lifting the pen at all. If you are to solve this mathematically, well, you will actually have to go and solve some graduation level questions and understand the concepts of eigenvalue and eigenvectors to arrive at this solution. But that's not what we do. What we do is understand the concept that the determinant of a matrix, a whole square, is the determinant of the square of that matrix. So in this next question, we have to find out the number of 3 by 3 matrices M with entries 0, 1, 2 such that the sum of their diagonal entries of M transpose M is equal to 5. Now the trick in this question is the fact that if you have a matrix M, then M transpose M, when you add the diagonal entries of M transpose M, you'll actually get the sum of the square of all the elements of M. If you don't believe me, see for yourself. Let's consider M to be equal to ABC, DEF, GHI. Then what will M transpose be? Well, M transpose will be ABC as the first column, DEF as the second column, and GHI as the third column. Now what's M transpose M's diagonal elements? Let's not consider any other elements but just the diagonal elements. Well, M transpose M has ADG in the first row, M has ADG in the first column. So the first element will be A square plus D square plus G square. The second diagonal element, in fact the element in the second row, diagonal element, well, that is going to be second row of M transpose multiplied with the second column of M. Well, the second row of M transpose is BEH. The second column of M is BEH. So the diagonal entry here is going to be D square plus E square plus H square. Similarly, the final diagonal element of M transpose M will be C square plus F square plus I square. So if you actually add all these things, what are you going to get? You're going to get the sum of the square of all the elements of M. So now this has to be equal to 5. Well, you could have avoided all this if you already knew that, and as soon as you saw the question, you would have had to consider A square plus B square plus C square all the way up till I square to be equal to 5, and A, B and C and D and all the way up till I can take only values 0, 1 and 2. So what are the different possibilities? Well, we can have one of these 9 entries to be equal to 2, one of these 9 entries to be equal to 1, and all the others to be equal to 0. This means that you will have 7 zeros and 1, 2 and 1, 1. In how many ways can you do this? Well, you can do this in 9 factorial divided by 7 factorial ways. Well, that's going to give you an answer of 9 into 8, which is equal to 72. There is yet another possibility. 5 elements could have been 1, 4 elements could have been 0, correct? Because then you have 1 plus 1 plus 1 plus 1 plus 1 equal to 5. So in how many ways can you do that? Well, you can do that in 9 factorial divided by 5 factorial, 4 factorial ways. Well, what is 9 factorial divided by 5 factorial, 4 factorial? Well, you have 9 into 8 into 7 into 6 divided by, well, you have 4 into 3 into 2 into 1, which upon solving is going to give you an answer of 126. So the total number of ways in which you can do this is going to be equal to 198, which is nothing but 72 plus 126. Well, the permutation combination bit of this is very straightforward and routine, really nothing much of a trick involved there. The only trick that was there was that you should understand that M transpose M, well, it will have the sum of its diagonal entries as the sum of the square of all the elements of M. If you remember that, you're going to save precious little time, which will be very handy in solving questions which don't have shortcuts and are really lengthy questions. So this shortcut would have saved a good 30 seconds to 1 minute of yours. Here is yet another very interesting question. So the objective in this question is to find the least value of a real number alpha for which 4 alpha x square plus 1 by x is greater than or equal to 1 for all positive numbers x, for all x greater than 0. So let's try and solve this question. But if you look at the question, you will most probably be clueless, because how do you proceed in this question? That is where your understanding of one of the golden rules of mathematics of 11th and 12th standard JEE syllabus comes into picture. Because I've told this repeatedly in my previous sessions of JEE analysis, that if there is one result that is of utmost importance, it's the result that AM is greater than or equal to GM. So when you see a question which has inequality and you're completely clueless, you are going to bank on that AM greater than or equal to GM. Because here I'm completely clueless and it's an inequality. Let's try and see if we can use AM greater than or equal to GM. So you have 4 alpha x square plus 1 by x. It still does not make a lot of sense to use AM greater than or equal to GM, because 4 alpha x square multiplied by 1 by x is going to give you a 4 alpha x. Not really helpful. But if I rewrite 1 by x as 1 by 2x plus 1 by 2x, right? 1 by x is nothing but 1 by 2x plus 1 by 2x. 2x into 2x is 4x square. Now 4 alpha x square multiplied by 1 by 2x multiplied by 1 by 2x is going to just leave you with an alpha, and now you can make use of AM greater than or equal to GM. So you have the expression 4 alpha x square plus 1 by 2x plus 1 by 2x. So I'm going to consider my 3 entities as 4 alpha x square, 1 by 2x and 1 by 2x, and apply AM greater than or equal to GM. A really important result in your 11th and 12th standard mathematics. So if you use this, you're going to get 4 alpha x square plus 1 by 2x plus 1 by 2x divided by 3. That's the arithmetic mean of these 3 entities, 4 alpha x square, 1 by 2x, 1 by 2x. That's greater than or equal to the cube root of 4 alpha x square multiplied by 1 by 2x multiplied by 1 by 2x. So now this 1 by 2x is going to cancel out with the 4x squares, and the left hand side is your expression which you are interested in. That's going to be nothing but 4 alpha x square plus 1 by x. That's going to be greater than or equal to 3 times the cube root of alpha. Now we want 4 alpha x square plus 1 by x to be always greater than or equal to 1. And we know that 4 alpha x square plus 1 by x is greater than or equal to 3 cube root of alpha, which would mean that your 3 cube root of alpha should actually be always greater than or equal to 1. Only then this condition will be satisfied. So your 3 times cube root of alpha should be greater than or equal to 1, which implies that your alpha should be greater than or equal to 1 by 3 the whole cube, which is 1 by 27. So the minimum value of alpha for this equation to hold true for all real positive numbers x is that alpha equal to 1 by 27. So the least value of alpha is alpha equal to 1 by 27. Again, this is not a question that a lot of you will be able to visualize as soon as you see the problem statement, because the way we have approached this question, AM greater than GM, where did that come from? After that, breaking 1 by x into 1 by 2x plus 1 by 2x, where did that come from? Well, this comes with a lot of practice of AM greater than GM questions and your ability to use AM greater than GM in inequality situations where you're completely clueless. So only if you have this intuition, you will be able to apply this trick and get this question correct. The next question is for those of you who love definite integration. Well, as such, definite integration and the chapter on integration is full of tricks. And this question is more tricks than normal. So here's the question. So in this question, we have to find out the value of the integral, negative pi by 2 to pi by 2 being the limits of x square cos x divided by 1 plus e power x dx. As soon as you see negative pi by 2 to pi by 2 in the limits, you are tempted to use the property of odd and even functions. But e power x, which appears in this question, that's neither even nor odd. So you cannot use any property here. But you can use the property of definite integrals, which is to split the interval. So if you have negative pi by 2 to pi by 2, you can split the interval into negative pi by 2 to 0 of this function here, x square cos x divided by 1 plus e power x dx, plus 0 to pi by 2 of the same thing, x square cos x by 1 plus e power x dx. Here comes the tricky bit in this question. I don't like that denominator, so I'm going to do something to remove the denominator, because if I remove the denominator, then things will become easy. So what I'm going to do is a trick which will not come naturally to you, but this is the trick that you will have to use. In this particular integral, let's put x equal to minus t. Then what happens? Your dx will be minus dt, and your limits are going to change. Your limits are going to change from minus pi by 2 to 0 to pi by 2 to 0. So you'll have negative of integral from pi by 2 to 0 of, well, you are going to have t square, cos of minus t is cos t, divided by 1 plus e power minus t dt. And we know that in integration, definite integration, the variable is dummy. So you can change x's with t's with no difficulty whatsoever. But notice here what happens is, because of the minus, your limits are going to switch and you're going to get a 0 to pi by 2. And what happens here? Well, e power minus t can be written as 1 by e power t. So this integral is going to turn into integral from 0 to pi by 2 of e power. Now there is a t, I'm going to change it with the x, e power x into x square cos x divided by e power x plus 1 dx, plus this same integral here without any change. Now compare these two integrals. Well, in both the integrals, the limit is 0 to pi by 2. The denominator is 1 plus e power x, and the numerator in one case is e power x multiplied by x square cos x. In the other case, it is just x square cos x. So if you add these two things up, what will you effectively get? You are going to effectively get nothing but integral from 0 to pi by 2 e power x plus 1 into x square cos x divided by 1 plus e power x. The 1 plus e power x's are going to cancel, and finally your integral will be nothing but 0 to pi by 2 x square cos x dx. This was a massive trick that you needed to solve this question. Split the integral, and in the first bit you are going to take x is minus t, so that your minus pi by 2 to 0 becomes 0 to pi by 2, and then add the two things up and you will simplify the integral. This is how you're going to do this question. Not a natural trick, but without this trick, this question is going to be quite Herculean to solve. I'm not even sure if you can actually solve this question without this particular trick. From here on, it's a very straightforward integration by parts question. Well, I'm going to consider x square as my first function, cos x as my second function. It's not fun anymore. It's just routine integration by parts. So you're going to get x square sine x between 0 and pi by 2 minus, of course, you will have integral from 0 to pi by 2 of 2x sine x dx. This term here is going to give you a pi square divided by 4. And the second term, unfortunately, you will have to use integration by parts again. You don't have any choice there. You take the 2 common out, so you are going to get x into minus cos x between 0 and pi by 2 minus of, integral from 0 to pi by 2 of minus cos x. So the minus becomes a plus outside. So x cos x between 0 and pi by 2 is going to be 0, because when cos x is 0, that is when x is pi by 2, the x outside is pi by 2. When x is 0, cos x is not 0. So in both these terms, this term is going to go to 0. So you are going to be left with pi square by 4 minus 2 times integral of cos x between 0 and pi by 2, which is sin x. Sin x at pi by 2 is 1, sin x at 0 is 0. So you're going to get 2 times 1. So the answer to this question is pi square divided by 2, pi square divided by 4 minus 2. The last part of this question is not at all interesting. It's routine integration by parts. The first part of this question is where all the tricks lied, and that's where this question becomes really, really peppy and interesting. Let's look at one last question here. So in this question, we've been given a function yn equal to 1 by n into n plus 1 times n plus 2 times n plus 3 all the way till n plus n all raised to the power 1 by n. Now we've been told that limit n tending to infinity of yn equal to some number L. The objective is to find out the greatest integer of n. Now, this is not a question which has any shortcut, but the trick that you must understand in this question has to do with Riemann sum. So you have to somehow convert this question into a form where you can get the Riemann sum. So for all of you who don't know Riemann sum, you'll have to go back and revisit and understand the concept of Riemann sum, because the trick in this question is to convert everything to the form of a Riemann sum and solve this particular question. So what we will do is, first of all, I will take that 1 by n which is outside the bracket inside it, so that we have everything inside one particular entity. So I'm going to write yn as n plus 1 by n multiplied by n plus 2 by n, n plus 3 by n, all the way up till n plus n by n, all to the power 1 by n. I could do this because in order to take this 1 by n inside, I'll have to take the power of n to the power n. So there are actually n's multiplied n times, because everything is to the power 1 by n. So that way I will get this expression, which can be rewritten as 1 plus 1 by n multiplied by 1 plus 2 by n multiplied by 1 plus 3 by n, all the way up till 1 plus n by n, and all of this is raised to 1 by n. So now I actually have some sort of a pattern that can be seen. So this is where we are going to use Riemann sum in some sort. So what I'm going to do is, now this is a product and for Riemann sum we need a series which is a summation. I have to convert this product. So a product can be converted into an addition using logarithms. So log of yn will be nothing but, of course, the 1 by n comes out first, and then you have log of 1 plus 1 by n plus log of 1 plus 2 by n, so on, all the way up till log of 1 plus n by n. Now I have a summation, correct? Now this is nothing but 1 by n, well, summation of log of 1 plus r by n, r running from 1 to n. So this is now in a form where I can somehow put in Riemann sum. We'll take the limit. Well, the limit and the log can be interchanged. So this can be written as log of limit n tending to infinity of yn to be equal to limit n tending to infinity of 1 by n summation r equal to 1 to n log of 1 plus r by n. Well, I take the log onto the other side from the left hand side to get limit n tending to infinity yn to be equal to e power, well, limit of n tending to infinity 1 by n summation r is 1 to n log of 1 plus r by n. Now this entire thing here is the Riemann sum, and this will be nothing but integral from 0 to 1 log of 1 plus x. So that's the Riemann sum there, and you need to solve that Riemann sum. Well, that's just a simple definite integral. If you solve that definite integral, you're going to get the value 2 log 2 minus 1. So you eventually have the value of limit n tending to infinity of yn, which is nothing but L, as e power 2 log 2 minus 1. Well, e power 1, well, that is going to be equal to just e. So that's going to be in the denominator. Well, 2 log 2 can be written as log 2 square. Well, e power log 2 square is nothing but 2 square. So that's going to be equal to 4 upon e. So the value of L is 4 upon e. 4 upon e is somewhere 1 point something, because e is 2.7. So L is going to be 1 point something. The greatest integer of L is going to be equal to 1. The final bit of this question is not the fun bit here. The fun bit here is, as soon as you see the question, you should identify that this is a question that will lead you towards Riemann sum, and you'll have to do all the manipulation to arrive at a Riemann sum. Well, when it comes to advanced math examination in JEE, you do not really have a lot of shortcuts, lot of tricks. All these are actually routine methods to solve the questions. Some of them can be labeled as tricks and tips. Mostly all these things will get into your system only if you solve a lot of questions, see a wide variety of questions. Because when you see a wide variety of questions, as soon as you see a question, for example, a question of this kind, you will understand that you have to use the concept of Riemann sum. Or in some case where there's an inequality given and no relation whatsoever, you will get this idea as to I have to use the concept of EM greater than or equal to GM. So these are tips and tricks which are for the trained mind, people who have actually solved a lot of questions. Believe me, in the JEE Advanced examination for mathematics, there aren't many tricks. There are a lot of tips that I can give you, and one vital piece of tip that I'm going to give you is practice n number of questions and practice them really, really well. If you like this video, please subscribe to our channel if you've already not done that. Every time we make a video of this kind, you will be notified then. I am going to be back with many more such videos. Till then, you have a great time preparing for your examinations, and I will see you very soon.
For more videos and live lectures on the JEE, click on the subscribe button now.